In this lesson, we'll look at which information about materials is needed during the selection process, where we can find it, and how we can organize it effectively. We've said that the choice of material is based on a specific property profile. That's why, for each material, we need to have clear information and reliable data that describe its characteristics. But where can we find this information, and how can we manage it effectively for the selection process? It's essential to know where to find data on materials. We can obtain it through direct measurements or by using sources that are already available both in print and online. Once this information is collected, it needs to be organized and managed properly. Only in this way can we accurately describe both materials that are already well known and widely documented, as well as those that are new, experimental, or just introduced to the market. Whatever the source, whether experiments conducted on materials or from databases, either in print or digital, the information must be reliable, from a known origin, collected using recognized protocols, and analyzed with statistical methods. Information can be presented in different ways. They can be numerical data, for example, when we state that the modulus of a certain material is between 200 and 210 gigapascals. They can also be qualitative data, such as when we say that a material is a good conductor, or whether it is transparent or opaque. And finally, they can be binary, when the answer is yes or no, such as when asking if a material is recyclable. This information can be organized or, as we say, structured in tables. In this form, the information becomes easy to organize, compare, and consult. For example, here we see one related to composite materials. Many of this information is common to all materials, which is why it can be collected in a single database. This becomes the starting point for comparing and selecting them. By comparing this data and taking into account the specific requirements of the project, it is possible, right from the early stages, to significantly reduce the huge number of available materials. For example, by applying a filter for a maximum density value, you get a narrower set of materials. Then, by setting a minimum value for the Young's modulus, the set is reduced even further. In this way, choosing the most suitable material becomes simpler, faster, and more effective. In addition to structured information, there is other, much more specific information about each material that we will call unstructured information. This includes the advantages and disadvantages of using a material, design recommendations, typical applications, case studies, or failure analyses. This information can be obtained from various sources, such as the designer's direct experience, technical reports, charts, drawings, and design guidelines. The combination of structured and unstructured information forms the essential foundation needed to effectively manage a material within a project. Structured information is generally easy to find and use, and they allow you to guide the selection of the material right from the early stages, when the number of options is still very large. Unstructured information, on the other hand, is not always available for every material, nor is it presented in a consistent way. For this reason, it is less useful in the preliminary phase, but becomes essential in the later stages, when the final decision about which material to use must be made. In project design, material selection doesn't happen in a single step, but is structured gradually, step by step. Let's look at a visual example. At the beginning, it's important to keep all options open, focusing on the widest possible range of materials without ruling out too many right from the start. As the project takes shape, we can start to set some initial limitations, exclude unsuitable materials, and finally narrow down to those materials that best meet the project requirements. So it's clear that different stages of the project require different types of information. In the early stages, it's important to have a lot of general data. It doesn't need to be precise, as long as it's reliable. Having a lot of data gives the designer greater freedom of choice when guiding the selection phase. On the other hand, when we reach the final stages of selection and design, the number of materials will be reduced. For these, it's important to have specific and detailed information in order to choose a material with confidence. To better understand what we mean by detailed information and level of detail, let's look at a practical example. Taking the polyethylene family as an example, we can describe it in a general way, considering all its variants, such as high-density polyethylene, HDPE, low-density polyethylene, LDPE, and reinforced or toughened polyethylenes, and so on, indicating the properties of the entire family through ranges of values. For example, we can say that the density ranges from 0.87 to 0.97 grams per cubic centimeter, and that the Young's modulus ranges from 200 to 1,500 megapascals. This represents a low level of detail, useful in the early stages of a project, when it is enough to have a broad overview of the material family. A high level of detail, on the other hand, means focusing on a specific material with exact values for its properties. In this case, for example, we might refer to low-density polyethylene, LDPE, and use the precise data for its density and Young's modulus in the project. To tackle a material selection process, we need to know how to find, organize, and manage a large amount of information. Today, however, unlike in the past, we have the help of databases, whether paper or digital, that collect and organize material data in a structured way. So let's look at how many databases and what kinds of sources we have available to find this information. Among paper resources, we refer to manuals or handbooks, such as those from ASM. However, with digitalization, everything has changed. Today there are platforms like MatWeb or Material Data Network, which collect thousands of technical data sheets from reliable sources. These tools not only allow you to find data, but also to compare different materials and filter them by applying multiple criteria at the same time. The web can also be a useful resource, but it should be used with caution. It's always better to rely on official websites, universities, or certified manufacturers. When you reach the more advanced stages of the project, with only a few candidates left, you need more in-depth information, technical data sheets, specialized manuals, and data obtained from experimental tests. This information is often unstructured and also requires manual analysis, but it remains essential for making a truly informed choice. Today, those involved in project design and material selection can also rely on specialized softwares. These contain a wealth of information on materials and manufacturing processes, making the selection process much faster and more effective. For example, ANSYS Granta software is a very powerful tool based on the material characteristics described so far and structured around Professor Ashby's approach. It offers detailed data sheets that combine numerical data, such as physical properties or costs, with visual and descriptive content. Another important advantage is hypertext navigation. You just need to click on a property or value to instantly access related sheets, in-depth explanations, or technical sources. Finally, it provides effective graphical visualization of properties. With tools like histograms, bubble charts, and interactive graphs, it becomes easy to compare different alternatives based on the needs of the project. A truly useful software for project designers, engineers, and designers. Based on the properties of materials, which makes the selection process more targeted, faster, and more reliable. In this lesson, we learned that material selection in a project is based on reliable data with a known origin. Material information can be presented in a structured, numerical, and uniform form, useful in the initial stages, or in an unstructured, very specific form, useful in the final stages of selection. During the development of a project, information needs change. Initially, you need general data on many materials, and later, detailed data on the few that have been selected. It's essential to know how to find and properly evaluate material data, which can be found in printed manuals or digital databases, and to pay proper attention to sources found online.